recording. Yeah. Okay. So here, mm, okay, okay. So now, okay. So we discussed about the traditional RAG pipeline, where we have some static documents and we created basically embeddings and then created vector database and implemented a application to use the data. Okay. So that is okay. I mean that works fine for the data which is there in our documents, basically a static for all static data. But most of the times actually no, that doesn't, I mean that is not enough actually, right? So most of the times we work with real time data. Real time data, basically we receive the data from upstreams, or we our application could generate some data like audit logs and all, store in our relational database systems. Okay. And there are some applications where uh, we have to work on, we have to act on some immediate transactions. Like for example, uh, in the last session also we have taken example as Swiggy, right? Swiggy uh, swiggy also integrated some real time chatbots, basically smart AI. Okay. So what these smart AI happening, I mean, are doing here is actually whenever we book a Swiggy, I mean, order in Swiggy, or whenever the payment gets failed, whenever there is a blocker here, like order is getting delivered delayed or whatever. I mean, operations, right? Those are all real time. Okay. All these transactions actually will be stored in their database somewhere. Okay. And but when you order and when you go to chatbot, and if you ask, okay, if the payment is failed, if you ask for the refund, it immediately answers, actually it immediately fetches the order which you have raised, and that chatbot actually is able to fetch the data, and uh, it will be able to resolve, actually, okay, payment is failed and your refund will be done in 1 or 2 days. This is the transaction details, whatever that information is there, that will provide. So that is the basically an action on the real time data, right, which is actually happening here. So similarly, in every organization, basically we work with, most of the times we work with real time data only, not historical data. Historical data are very rare cases, right? Rare cases actually. But when we are getting the data from upstreams in real time, and if you want to build a chatbot to work on with their data, so the traditional RAG actually doesn't help on that. So what we have to do is, here we have to build a dynamic pipeline, basically a real-time pipeline, RAG pipeline, where it can fetch the data from where it can integrate the real-time data into vector databases, and use the data for generating some real-time responses from the LLM, actually. Okay. So how to do that? So yeah, this is not, I mean, a new technology or new setup and all, because we use traditional RAG only. But what we do is, instead of the static documents which we used for here, for creating embeddings and all, what we will do in the real-time Gen AI, or real-time RAG implementation. So what we will do is, so we will actually build a pipeline where it can feed the real-time data into vector databases. Okay. So how to do that? So here again, there is no standard or there is no predefined framework where we can use it for all the problems. Okay. It's not like that. Okay. So based on our problem, we have to think about that, and we have to build some pipeline to do that. Okay. For example, here I'm taking an example. We have an application called most of the, I mean, banks are like investment banks and all, right? We receive the data from different sources, actually. Okay. This is an application A. Okay. Basically I would say here the trading is actually happening here. This is a front office application where users will use this application for booking trades. Okay. So the data actually flows to different downstreams. I mean, I'm taking a real-time example, actually, where we work, actually. Like, our organization is basically an investment bank, and we receive data from upstreams. Okay, like this. Uh, so we are into a back office application where the actual settlement will happen. Okay, whatever trades are booked here, all the trades will be settled at the back office application. Back office application, and but how we'll get the data? We'll get the data from different sources actually from the upstreams. So here for for our in our use case actually here this application A actually sends data to application B, that is actually another application. Okay, here application B from A to B actually here we are using actually Apache Kafka. Okay, you might heard about Kafka, right? Kafka is actually widely used in applications actually on the distributed platforms where you have data, and if you want to exchange the data from system A to system B. So Kafka is the the best solution actually as of today. There are many messaging systems, but Kafka is really good for that solution. Those kind of problems. So here we receive the data from application A to application B through Kafka. Okay. So in Kafka we have a topic, and the topic actually receives, and there is a producer and there is a consumer, right? So consumer actually consumes from the Kafka topic and process the data. Okay. So here we here this is this is the flow, and if you want to build a real time chatbot for all the real time trades whatever are booked here, right, in application A. So what we have to do is, what actually we did it in our application in our organization. So from application A we are actually receiving the data through Kafka, right? Here we receive data from Kafka, and here we have built an application actually where it reads the message from the Kafka. Basically here this is actually a consumer. So we receive the messages. The message is actually some information. Basically here there is a trade information, like what is the trade value, who is the counterparty, and what is the date, what is the amount, what is the quantity. It has more information actually in this data, and this consumer actually what it does is it extracts the data. It basically it consumes the data from Kafka. This is basically a messaging system here actually,
Hmm.
right, for streaming, and the message whatever messages are coming from the application A, right? So application A pushes a message that comes here, message 1, message 2, message 3, something like this, and up to n messages. So this consumer what it does is it's real time, right? Kafka is the best for streaming, data streaming. Like it can push 1 million messages in per second actually. In second, 1 million
Hmm.
messages can be transformed through Kafka actually. So it's very powerful, and performance wise it gives the best actually on the distributed environments. There could be multiple consumers also where it can consume the same message actually. We can build parallel consumers actually to read the data simultaneously from the Kafka. Okay,
Hmm.
so here we built a consumer here, which actually connects to it. It actually gets from the, it gets the messages from this Kafka. This is actually called in enterprise messaging systems we'll call it as a queue, but in Kafka we'll call it as a topic actually, right? Topic, and from topic we read the data, and so here whatever component we have written here, right? This component actually uh, reading data from here, and this here we built another component which actually does that part, like we integrated this channel with the pipeline actually, a RAG pipeline. So here we have embedding here, embedding, basically extraction of the message, and it will create chunks, and from chunks it will create tokens, and from tokens it will generate embeddings. Those embeddings actually will be stored in the vector database. Okay, so this is the core part of this application actually. Okay, so data streaming is very very important, right? See, the remaining the remaining application actually implementation remains the same only. You have an application here, and here you have an LLM here. Okay, you are using LLM. There is no change in this part. No. So the core part is actually here to build real time pipelines. So this is a continuous process. It runs 24 by 7, 365 days, and continuously receive the messages and comes here, and it goes to vector embedding. Vector database here. Okay. So here we have a chatbot. Okay, we have a chatbot, and This chatbot actually has the same, I mean, RAG pipeline implementation. That here it goes to vector database, gets the contextual information, it sends, I mean, it creates the prompt and it will send to LLM. LLM actually uses that knowledge and then returns back to the user. Okay, so for example, uh, this is exactly similar to the example which I have given actually, that Swiggy example. Swiggy or Zomato, I mean, all will work with real time data only, right? Not historical data, like not some old orders and all, right? All real time. So here what happens is, for example, as a user, you logged in into this application and you booked a trade. Okay, you bought some shares and you booked a trade here. This is a trade booking application actually. Okay, trade booking application, and whenever the trade gets booked, the data actually flows through this channel and it comes here, and then it will be stored in the vector database here. Okay, so now this vector database is actually getting updated in real time. It will have, within seconds it will flow to vector database. Okay, this is flowing from this Kafka, right? So within seconds, or I mean within milliseconds, the data flows to vector database. Okay, and if you ask, okay, for example, uh, how many trades are booked or whatever, I mean, recently or in last 5 minutes or last 10 minutes, so it can go here and it will have the timestamps also, right? Whenever the trade is booked, trade will have the timestamps also. All the data will be here in the vector database, and it will vector data. It goes, the request goes to vector database, and it gets the top three documents or whatever, and then it goes to LLM, and LLM basically responds. I mean, generates the response for that. Okay, so this entire, I mean, this entire pipeline is basically a real time RAG pipeline. Okay, so this solution actually works for our requirement. Okay, but same thing can be used for other requirements. No, for other requirement, basically other use cases, they might not receive data from upstreams through Kafka. There could be a different channel. Okay, there could be they have their own front end application, and that is only feeding and getting the data. So based on the data channel which they have, right? So the solution also gets changed actually based on that. So that's why I'm telling, there is no fixed solution for implementing these real-time Gen AIs. That actually depends on the problem which you are actually working on. Okay,
What is this method called?
this is real-time RAG or real-time Gen AI.
Okay. Okay. So the information, the accuracy of the information or the response depends on how frequently or how recently
Huh.
you have updated the vector database, right?
Yeah, yeah.
So isn't so my understanding,
Hmm.
if when you are working on embeddings,
Hmm.
isn't it a costly affair? Every time you create or update your embeddings, the vector database, um, like how big is that,
Hmm. Yeah, yeah. So
or how
here,
costly is it for the vector database to um, recreate all the embeddings?
yeah, yeah. So as per the metrics and the feedback from different applications and all, vector database could go up to 500 GB actually. If it is more than 500 GB, it will enter into the performance issues and slow responses and all actually. But up to 500 GB, it is okay. So here what happens is, when we work with real time, this one, how long I mean, how long which we need to keep this data in this application, right, in the vector database, right? That is also important.
Yeah, how long it,
So
it take, usually, like, it is time consuming, right? Whenever you are adding new data, I don't know, like, is it time consuming for it to create new embeddings and update the vector
mhm.
database?
It's not a
Because,
time, it's fast
oh,
only.
is it?
Hmm.
Oh, okay.
It's fast
Because
only.
if it is transactional, do we need to have a balance between how frequently you update and how many transactions you update
Hmm.
as well?
Here,
Because you may be getting a lot of new information. So Is it a costly affair to keep it up to date with every transaction, or do you do it in batches? Is my question.
Mm,
Yeah.
yeah, yeah, but here the problem here which we are talking is actually 100% real time, right? My my
Okay.
my my chart my chatbot should be able to answer the data
Mm,
which is generated or which is created, in 5 minutes ago or 2 minutes ago. I mean, anytime, right? So
mm, mm,
so here we cannot keep it batches actually, because batches actually work with historical data only, right? So last 1 week or
mm.
see I mean,
It should be real time.
it should be real time only.
See, the reason is like if my transaction got failed
Mm.
and if I'm querying in next 2 minutes,
Hmm,
and if you don't get that data,
yeah,
then you'll be in panic situation, right?
yeah, your
You'll
chatbot doesn't
not
answer,
know.
right? Yeah.
Yeah, your chatbot will not answer. So all this Kafka is more like it takes the real time messages,
Hmm,
right, and then updates the source, whatever target I would say, in real time.
yeah.
So that's when actually you can get the accurate result. Let us assume that you, to your point, you created a batch or a process or a scheduler that updates in
Hmm,
any every half an hour, right?
Yeah.
So
Why
that
I,
means
why I am saying batch is because you are not storing in a relational database and fetching it, right? You are converting all the new data into embeddings and storing it into vector database, which itself is resource
no
and
resource
time.
consuming, but how
hmm,
fast it is. I think it's very
Yeah,
fast.
I don't
hmm.
know. That's
So,
that's my question.
Ah,
How
yeah.
fast can you update
Fast,
your vector database?
fast only. It is message by message,
Okay.
no?
See, now here you have to understand why we are using vector database instead of a traditional relational or any other database. Vector itself says you have multiple directions X, Y, Z, or anything else. So you can proceed in any other way. You are feeding real-time data or structured, whatever it may be, or specific ones. So it will expand, it will store it in different ways. Now this model will be looking into that database. Whichever it is suitable, it will throw you the option. Now you got it. Instead of using
Mm,
a traditional or
Hmm.
relational, that's
No, no.
why we are using
Yeah, yeah.
yeah, vector base.
Yeah, here traditional database, that is not a choice only, because that doesn't work with.
No, it will
Uh,
fail. We
hmm,
are having only
hmm,
I think
2D types of data.
hmm.
Prasad's question is how
It,
fast
it
it
is
is.
it is fast only, because the messages which we will have in
So I think now we need to know that how many messages it can process
no,
within a
it is
second.
message it is message by message here.
Message, even though it's message by message, how many messages will it process in 1 second, right?
Yeah,
So,
yeah. So
yeah,
so if we
because
know,
here
if if
Kafka is.
updating, okay, my question is this: if
Hmm,
updating a vector database, because when we started, what are the three challenges? Preparing data sets,
hmm,
infrastructure costs, and time costs. Right? These are the challenges, right? If
hmm.
when you are fine tuning an LLM,
Yeah, yeah.
or fine tuning, or every time you give data, you create embeddings, and the
Hmm.
vector database takes time to get ready, right? But in this case, if you are saying, okay, real time, I can do that. My question is, how quickly can we do that? Can we update a vector database? If it takes time, what is the approach that works here? If it doesn't, then it is really good. I
It
really,
doesn't take. It doesn't take
and
actually. It's fast only.
yeah, it
uh,
doesn't take, and moreover, this real-time transaction, the volume of data that is going to process is less.
okay.
See,
Yeah,
But
yeah.
when you
one
look at
question,
the
one
yeah,
question here. Okay, I have to stop you there.
Hmm.
One question is, my doubt is, updating a vector database, is it that the time it takes, does it depend on the volume of change you are making?
Mm,
definitely right.
um, that
I
the
don't know.
no, 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 that no, the time. See here, what happens is you have some data. Yeah, your question is valid question actually. Here, you have vector
Okay.
database. You have vector
Yeah,
Then let us
database.
assume that
you have a
what is the
20
time?
GB vector
20
database. Okay.
GB is there.
You are only changing 1 MB. You are adding 1 MB
Huh.
versus you are adding 100 MB. Is there any difference in terms of time that takes depending on 1 MB or 100 MB? And also, does the vector database completely change even with a small change in the input?
It won't
Because when you
change.
say it has
It
to
keeps adding
recreate
actually
all
here.
the
Hmm.
embeddings,
Hmm.
right?
It's more of
Hmm.
adding, I believe. Yeah.
Yeah, if it is a delta, that's okay, understandable. If it is a small delta,
Delta
it
only. Yeah.
doesn't change
Hmm.
everything. Okay. Yeah.
Delta, and it is
Okay.
fast only because here the example which we have taken, right here, what will be the, say, we are talking about the trade data, right? So trade data,
Mm.
there would be
Data
some
itself will be structured, first of all.
structured, yeah, there would be 20 or there would be 10 fields actually, right, to represent
Yeah.
that record. So it will be fast only actually, it won't take much time.
Mm.
uh, if it takes time, there are again tools actually. Here we have to use, I mean, how quickly we are parsing and tokenizing and creating embeddings. There it will take time, actual time. So here, I mean, this article is a good article actually. When you get time, go through
Mm.
this.
Link to prevent hallucinations. Yeah. It
Yeah, yeah,
has to be accurate as well.
yeah, yeah, yeah.
Because when you say vector database, you cannot guarantee the accuracy, right?
Mm, yes.
Yeah.
So our data also should be clean actually, right? Okay, if you give some junk data
Mm.
and then you're expecting some responses, then it won't answer. Okay, it's all depends on the input
Okay.
actually.
Even if it is clear structured data, is it accurate? 100%? I don't know.
Hmm.
When you query a vector database about something, how accurate is it? Can you guarantee 100%?
No,
Or
we cannot
uh,
guarantee. So here, that's what I mean.
that's what is this article? Yeah, hallucination, avoiding
Yeah, yeah. Here, the RAG which we discussed and the RAG which we implemented is very basic RAG actually, right? Basic RAG. I mean, we are just
hallucination.
putting vectors and then doing this, right? But
Mm,
to improve the accuracy, there are different techniques actually which we have to build on top of the basic RAG. Okay, so those are actually some advanced techniques, advanced RAG techniques.
mm,
We will talk about in the next session. Yeah, okay, and yeah, but once we add all these techniques, right? So that definitely that will improve the accuracy and the responses will be more relevant and accurate actually.
yeah,
From
yeah,
Gen AI, we will never expect
yeah. Because this is transactional. That's the question.
yeah, yeah. Like, so for example,
Mm,
if your data is there in your RDBMS, and when you write a query, select query, what is the average of top 10 top 10 employees or 100 employees?
accurate. It could be accurate.
It will be accurate, right? It will be 100% and then it gives. But here it
Mm,
won't work like this. So
yeah.
uh, yeah, even the response also changes every prompt, right? Even if you give it to Chat GPT or any,
Mm,
if you copy paste the same prompt again and again, you won't that won't give the same answer again and again. It changes the structure. It adds more relevant and
so it depends
sometimes
on the nature of the application. So
huh
you restrict the randomness
yeah.
and yeah, okay, work towards the strictness.
Yeah. So this concept is very, very important. So just to understand and implement some real-time Gen AI applications
Can you
because
share this link to this in the chat as
yeah,
well?
yeah, yeah.
Yeah.
So this is basically the future of AI basically, right? Where we are talking about replacement of developers and all, right? So when we automate when we automate our existing applications into real-time Gen AI applications, eventually that would replace employees, right? So for example, same example we can take. Okay, in your organization there are some 10 to 20 production support engineers which they are working on to support your application. So you built an application with this real-time RAG, and after 2 3 years what happens? They don't keep the 10 20 support engineers, right? They will keep only 5 or 10 support engineers, and they will use this chatbot, the production support actually. Okay, whatever manually people are doing, right, this also could do the same thing more accurately than the manual things, right? Manually they have to log into the servers and check the logs and all, right? But this one, it does actually. So this is very, I mean, important thing, and this is what, the scariest thing actually right here. Like, if you don't implement, an efficient AI application, what it does, you always get some junk answers and, some
Hmm.
incorrect responses, right? So if you want to make it more, real time and more accurate system, then we have to implement all these, the latest things, latest advanced technologies and techniques and all, right? So that is where it differentiate actually. If you implement very basic and then, okay, it will replace your team, then no, it won't. Again, they have to recruit more people to, work actually, right? If that doesn't work, perform well. So this is a classic example actually. Please go through this. I think YouTube video is also there. Just to understand this. Here, they are using basically, even in our application we are using Kafka. Apache Flink is basically a streaming framework from Apache. It's an open source. So they are using Kafka and Flink actually to prevent hallucinations. And here they have shared code base also. I think you could do the same thing. So do one example actually with this real-time JAG implementation. Yeah, contextual enrichment, integration and flexibility. I think, yeah, YouTube video is also there. You could watch this. Okay, generative AI in the travel industry. I think, yeah, this is the one.
Hmm.
Yeah, I think it is good one actually. So go through this. There are many. I mean, this is, I felt this is one of the good examples, but there are many actually. So you could try. Here, this medium also has, but it's not full. I think it requires some license. I think, but the concept remains the same. Here they implemented code base also actually in the medium link. This also you could explore.
Yep.
Okay, just a minute. This one, but this requires license, I think.
Can you paste it in our WhatsApp chat group, maybe?
I will paste. I will paste. Yeah, here you
I
see
don't
here.
know.
Yeah,
Access
corpus
this.
document embedding, vector embedding. This is also real-time only. Introduction to real-time RAG. Okay,
Hmm.
this corpus and vector database. Same concept remains the same. Similarity, context
Yeah.
and brush, the same. Okay, this is the data flow. They are using this. Okay, here code is also there, but I think you don't know. Full article is
Hmm.
not there. Only it requires upgrade. Upgrade. Yeah, there are many actually. Here you could try in YouTube also. You will find many. And using Redis and real time goes beyond the vector database. Okay, and let Flink cook mastering real time retrieved augmentation. Okay, real time with Pinecone. Okay. RAG with real time. This is from open source actually. I mean, sorry, this is from OpenAI. Okay,
Hmm.
and RAG with real time data. Many you will find actually. So try to implement one of them. You could think about your application only. So just like building a production chart bot where it could monitor your application actually, like by reading the logs, connecting the system, different systems, and getting the status and all. Okay, so try one of them. This is really interesting, and the main thing is actually here you have to build actually. You have to build the real-time pipeline here.
Hmm.
Okay, and
So what frameworks are available to that will update the vector database in real time? Are there any?
that is here the thing is generating the embeddings and storing, adding to the vector database code remains the same only, but how frequently we are running that
Yeah.
thing.
Okay. Hmm.
Yeah. Here, for example, I will show you. Yesterday, I mean, last week, I showed you the code right here, RAG with Gemini. So here, I have written a PDF loader, which actually reads the PDF files from PDFs, right? I mean here.
Yep.
So you can build a process to write the PDF files and copy into here, and every 5 minutes or every 10 minutes you can write in another job to run this PDF loader and generate the embeddings. Okay, both could run parallelly, right? So one after another
Instead of
like.
PDF, you use Kafka and stream that to the
Yeah, right. That's it.
or
So,
IBM. It is like IBM MQ, na? MQ series and everything.
yeah. IBM MQ, IBM MQ,
ఇప్పుడు
TIBCO.
2001 లో వాడిన ఎంక్యూ సిరీస్
Oh,
ఎంక్యూ
okay.
సిరీస్ అనేవాడు అప్పుడులో
Yeah, MQ series. Yeah, that is IBM MQ. But here, this is like technology change, right? This messaging systems have been there for many years, more than 30 years when it started, IBM and TIBCO and all. But now the technology has been improved, and Kafka is like streaming. I mean, real time actually. If you use other messaging systems like IBM MQ or Rabbit MQ and all, right? Rabbit MQ is also EMS. Basically, that is called enterprise messaging systems. Actually, those are actually EMS softwares. Kafka is not an EMS. Kafka is basically a message streaming.
స్ట్రీమింగ్ కి
Uh,
ఐ థింక్ స్ట్రీమింగ్ అనేటప్పటికి ఇందులో ట్రాన్సాక్షన్ దానికి యూజ్ చేస్తారా అక్యురసీ ఉండదేమో కదా మరి అయితే
no. The
కాఫ్కా
the message, no, streaming is like real time streaming. Like, so the message which is coming in the some format, right? You
బట్
the
డస్
in
ఇట్ గ్యారంటీ బికాజ్ ఐబిఎం ఎంక్యూ రిలయబిలిటీకి ఉంటుంది దే
Kafka also guarantees. Here they have replication servers. Same messages will be there in multiple nodes. One of the nodes goes down, automatically it will be retrieved from other nodes. It has full. This is basically a distributed system application actually. It works with distributed servers actually. So yeah, it 100% guarantee. 100% messages guarantee. In this Kafka again, it is a big topic. In the Kafka we have that automated acknowledgement and manual acknowledgement. Whoever consumes, right, they can send an acknowledgement actually to confirm that message has been successfully retrieved or received from the Kafka. So that is there.
Actually, we have used Kafka. It is a good one.
Yeah. Many companies are using because data flow. Now the data is very huge, right, from the upstream applications and all. So that should flow quickly and in real time. Like see, that depends on the nature of the application also. Okay. The example which I have taken is actually a trading application, right? The trading, when you imagine when the trading starts in the morning at 9 a.m. and all, how many users will connect and book the trades? Very huge, right? It will be in millions, right? It will be in millions. Sometimes the system will get crashed also, right? The booking applications will go down and all, right? So volume wise very huge. When we deal with huge amount of data like this, so definitely we should have the streaming messaging systems like Kafka. Okay. So there are other messaging systems also, but this is widely used actually. Okay. Now coming back to, yeah. So any questions on this real-time Gen AI or real-time RAG implementation?
In next section, you will get.
Okay. So now, I mean, we know that. I mean, we have data from different different front office application, front end applications, or upstream applications, and we can build pipeline like this. Okay. Next, the next topic is actually uh, working with RDBMS. Okay, this is really interesting use case. Okay, so here our classmate only, I think Aruna only, I think she is working in Walmart, right? Uh, they have a, I mean, really interesting use case. So whatever data, Walmart is basically this application, right? Online uh, product sales application, right? Like Amazon and all.
The store actually, it's a store, grocery and whatnot. Everything.
Yeah, everything actually. Like, I mean, Walmart only bought Flipkart, right? Yeah, Flipkart is now Walmart. Yeah, so basically, I will take their example only. I think that is more relevant and you could understand quickly. So Walmart, what they're doing is they receive the data from different sources actually. Okay, different sources, content sources like Insta. There are posts on Walmart products and all on Insta. Uh, and other social media also, like I think some job openings and all other from LinkedIn also, I think, right? So some of the posts also will be there. So mainly from actually from Insta they will receive a structured, I mean unstructured data. And they have systems to store unstructured data. Actually, basically they are using Azure cloud and storing all the content actually, which is actually coming from this Instagram and to the content stores actually here. Okay, so here uh, they have RDBMS also, and this unstructured data and all we can store in. There are databases actually like Azure. I mean, if you take AWS and all, they have a service called S3 bucket. S3 bucket, basically you can dump anything whatever you have. Actually, you have video files, you have audio files, you have images. You can directly dump here. That is in the
You
form
can
of
use MongoDB.
MongoDB is basically NoSQL database. uh, yeah, so there again we have to convert that data into there are tables and all, right? So you have to use the tables and because NoSQL actually, right? uh, so here uh, they're storing in the cloud services like S3 bucket and all, and then they're storing in some data actually they're storing in RDBMS also. Okay, so now they have huge amount of data in their RDBMS. Okay, here they have used data in RDBMS. They have some 100 GB or whatever, I mean 100 GB, 200 GB or whatever, 1 TB also, I think in most of the cases, I think, yeah, TBs of data. So now their requirement is they want to build a chatbot. Okay, they want to build a chatbot. It should actually work with the data which is there in the RDBMS. Okay, the I mean the response is like in last 1 hour, how many customers have given positive rating for this product. In last 1 week, how many products got good reviews or ratings and what and all. Okay, but data everything is there in RDBMS. So their queries are like this actually, right? So currently there is no existing system to give that information actually in their setup. Okay, so now they want to use this Gen AI, basically Gen AI, and that should be able to answer all these queries actually, whatever the customers have. Okay, uh, so here, I mean here the problem is the content is actually in RDBMS. Okay, and that is also very huge, 1 TB or 2 TB of data, right? That is also very huge. So the approach which we discussed, right, taking the static data or dynamic some real time data and create make it in chunks and then create tokens and then embeddings and then store in vector database and all. Okay, so that solution is not suitable for this requirement. Why it is not suitable? You have huge amount of data, right? You have some 2 TB or 3 TB whatever data you have, that is also in RDBMS. And RDBMS, and in RDBMS again the structure is very complex, right? You have many tables and many tables have relations, right? Relationships. You have parent child relations and you have that has multi levels also, right? So the data model in the RDBMS is very complex, and we cannot directly extract the data from RDBMS and put it in vector database. That is not the solution, because the data itself is very huge, and to fetch the data from those tables also it's not easy, right? You have hundreds of tables here, and which table you will feed and into vector database and then store it. So that solution whatever we discussed, that is not suitable for this requirement. Okay, so how to handle it? Okay, how to address this problem? Okay, so here uh, so there is a way to do it actually. So here instead, I mean, instead of storing that data directly from, I mean, RDBMS into this vector database. So here what we have to do is, here you have an RDBMS, right? You have an RDBMS. So this RDBMS has the DB schema, right? This schema, we have to take the schema from the database RDBMS. We should not actually create vectors for the data. We should actually take the tables or schema for your database from the RDBMS. For this schema, actually we have to create vector embeddings and store in the vector database. Okay, so here we have to take this schema and then do it actually. Okay, store it in vector database, generate the vectors, and this will not be used, right? This is again a one-time activity only. We don't frequently change schema, right? I mean, if you change also, you can make it real time. But whenever the schema gets updated, do this step, and then most of the times it is very static, right? Like, I mean, once in a 6 months or once in a 3 months also we don't change actually. I mean, if there is a new development, we change it. But if it is an existing application and it has been running for many years, then we don't normally touch this schema. If you change also, there is a solution actually, right? So we'll build a real-time RAG here. Yeah, just assume that there is an existing application and has been there for many years, and there is no change in the schema. So what we have to do is take the schema and then create vectors and store in the vector database. Okay, so here, uh, yeah, we have the schema in the vector database, and how does the chatbot or LLM know about the data? Okay, so here only the concept comes actually. Here there is a concept called natural language to SQL. Okay, so natural language to SQL, basically this is again a concept actually. Users actually will give natural language, and which will internally which will be translated into an SQL. That SQL actually, once we get the exact SQL, I mean the correct SQL from the system, we should execute that SQL and get the data. Basically, again we have to build in another application here to connect to RDBMS and run the query here. So query will be executed here only. Okay. So how does it work actually? Basically here, when we store the schema in the vector database, so here we will implement this RAG pipeline actually here, right? And here, I mean, the question is actually like this. Okay. In last 1 week, how many users have given a positive report for Sony television or whatever? I mean, whatever was sold on that Walmart site. Okay, their users are. I mean, this is the query. Okay, so what are the positive reviews which are given for this Sony TV in the last 1 week? Okay, that information is there in RDBMS. There are review tables, there are product tables, there are other tables, all are there in RDBMS. Okay. So this is the natural language which we give to the chatbot. Okay. So what it does is take this query and this prompt actually goes to here vector database. So based on the query which is given here, the prompt which is given here. So what vector database does is, vector database has the schema, right? So it actually gives the schema information, the schema data, whatever I mean relevant to this query, all will be retrieved from the vector database. Okay, that will be retrieved here, and in the prompt, okay, the context here is actually schema data, schema information actually, schema info, and the query is actually here. Okay, and the prompt, everything, all three will be embedded, and that will be sent to LLM. So here you have an LLM here. Okay, this goes to LLM. So what LLM does is, LLM actually what it does is, it actually generates an SQL. Okay, it doesn't give the response which what user is asking, like I mean 10 users or 20 users, because in the prompt we are sending the contextual information, and in the prompt here, actually the prompt is the key here again. In the prompt actually we have to write we have to use all the prompt engineering techniques here, like one shot prompting, zero shot prompting, that two shot prompting, chain of thoughts prompting techniques. We have to apply all these top techniques here and create prompts here. Like prompt would be like uh, use this schema name, only those columns which are there in the schema only. Don't hallucinate the column names or table names and all. That should be given in the prompt itself. Okay. So, say for example, for this query, the prompt would be like, okay, it should use the actual schema details and don't hallucinate anything, and use the exact column names only. Column names also it can hallucinate, right? Like based on the prompt, it can change actually, right? It can add some own column names also. When you run that query, the query will fail, right? Because when you run the query, eventually will be executed on the RDBMS only here. Okay, so that is how whether
Yeah,
real.
keep it. So instead of fine tuning the vector DB with the actual data, you are telling it the schema only. Okay.
Yeah.
So when you pass the query initially, the vector DB will give you the schema back, right?
Yeah.
So who creates this SQL from the natural language?
LLM only creates. LLM
Okay.
here we are sending the prompt, right? Here we have a query which is actually from the user, and prompt information and the contextual information. Context is actually from vector database, right? Which we are getting here, and
So you are getting, so what is vector database's um, job here?
vector database's job is actually to give the relevant schema which is based on the query.
Okay. So yeah, based
The,
on the query, it gives the relevant
hmm,
schema,
hmm,
and you pass it to the LLM, and the LLM now uses that relevant schema and fetches the data dynamically from
hmm,
the RDBMS.
that comes later. So here
Hmm.
in the first step, this natural language to SQL happens here. Okay, now we got the schema from the vector database, and then all prompt and query schema will be sent to LLM. LLM actually uses its knowledge to generate the SQL. Okay, we will mention the database name also, like because some SQL syntax is different, right? Like Oracle has its own syntax, and if all databases follow ANSI SQL, it is okay. But most of the times, the joins and all, each RDBMS has its own syntax. Like for example, Sybase has its own, PostgreSDB has its own syntax for
Hmm.
joins and all.
One
So,
question.
hmm,
Where is this SQL generated from the natural language? Here.
this one LLM only
Hmm.
here.
LLM. Okay.
LLM
Because,
only. LLM has more knowledge on. While training, they trained with Oracle
hmm.
database syntax and PostgreSDB syntax and MySQL database syntax. Everything, na? All knowledge. All database related knowledge. It has that.
Not from
Uh,
the bot, right? You because you
Not from the
written.
bot.
Uh,
Writing the query, it has the knowledge. Okay,
mhm.
writing the query, it will use the schema. From the schema is basically the context schema. It is not exactly how the database schema is there. Vector db, it could written anything, right? Like it could written top 3, right? Top 3 or top 5, whatever.
Hmm.
And but here LLM actually uses its knowledge to build the right query.
Hmm.
Here the challenge is column name, table names, column names. It should be more relevant and more meaningful, right? If you give column name xyz and you're expecting some amount, right? It doesn't do, because xyz column is in the schema, doesn't make sense, right? So you're
Hmm.
expecting some amount data from this column, then the column name also should be amount only, not xyz, something like that. It should be more relevant actually, meaningful actually, while building the schema and uh, database. That is how all projects anyway, they will follow standard naming conventions for the tables and schema and all, right? So that is not a problem. And yeah, so here the thing is, LLM actually uses its knowledge and generates the SQL here. If chatbot gets an SQL here, okay? So we cannot, what next? After this, what next? Okay, once chatbot application basically gets SQL, we have to build another application. Okay, it could be in Python, it could be in Java. We can call existing also. Here, this is another application actually, which actually triggers this query on the database. Actually, it connects to this database, and the actual query runs here only on the database only. This actually gives the response, right? That response again will be written back to this application, and this will be given back to the chatbot, right? So this query will be like very raw format, right? Not in the user understandable format. So after
You
that
need
one,
LLM again?
again we need an LLM. We have to change
Oh,
this. We have to send this output back to response from the select query to LLM.
transform it. Yeah.
Yeah, and we'll generate this, user understandable format. Then it will give the meaningful format actually, right? This 100% works because I have done some research, and many of the companies already implemented this approach actually. LinkedIn is one of them. LinkedIn has uh, natural language to SQL bot, something is there, okay, for their system. We could do some search actually. So, but it actually works. They also, I mean, Aruna also tried. Their team also tried, and it's working.
What is the name of this technique called?
Natural language to SQL.
No, traditional RAG. We discussed about traditional RAG process and real-time RAG.
Huh.
So this
The,
is
this is uh, this is
It comes
also
under real time, real time.
we
no
can. And in
real-time.
RDBMS, real time only. Real time
Yeah,
in real time. This is another way of fetching the data
another
from
way.
RDBMS. Yeah,
Real-time with DBMS. Okay.
yeah. Real time with RDBMS only. Where did we keep our topics?
Real-time RAG
Uh,
with
uh, I mentioned
RDBMS.
somewhere. No topics. Yeah, topics here. Yeah, topics here. Natural language to SQL with RAG. Real time only. It comes under real time.
Yeah. Mm.
Okay. So this is very interesting. But what is the accuracy, and that depends on how well we have written the prompts. Okay, prompts, because here if you see, this is very good.
Prompt as well as LLM that you are selecting for this thing.
Yeah. Here, uh, I have write in SQL. This anywhere writes, right, query. I mean, if you give write in SQL to fetch data from employee table, okay, and department, okay, uh, for all the data for all the managers, something like this. I mean, this is natural language, right? I mean, I am giving the prompt here. If I give this, it will generate SQL, but it uses its own schema, right? Here, very generic employee, select distinct manager ID, employee, manager is not null. It has given employees to department to show each department's manager. This has given another query, list managers with this query. So basically, it has the knowledge. Okay, it has the knowledge to write SQLs because it got trained. Okay.
Let me
Uh,
put it in this way. Naidu, sorry for interrupting.
hmm,
Ah, Let me put it in this way. Natural language means ordinary English language. Fetch
hmm.
me the rows from employee table and department table. That's it. Automatically, it will generate the SQL. It will fetch you that thing. It will give you the schema, everything.
Hmm.
All dependent on LLM.
Yeah. Yes. So
Got the
here,
point, Raju?
Yes.
Got the
yeah,
point?
Yeah.
yeah. So here, if you see natural language to SQL, you find many articles. Some real-time implementations also. Like here, you see NLT with BigQuery. BigQuery is another service actually in Google Cloud. From this, it is fetching. Okay, build a robust text. I mean, I think we can call it as a text to SQL also. I mean, yeah, build a robust text to SQL solution generating complex, taking to how natural language to SQL. Okay, and natural language to SQL is this one, and
So you
uh,
you you provide the query and the schema as well as input.
uh,
You get the SQL.
yeah, we queries will ask in natural language only. Based on the natural language, it fetches the schema from vector database, and
Yeah.
that will be given to LLM. LLM will generate an SQL. We'll get SQL in the background, in the behind the scenes. We'll get an SQL. That SQL will be triggered on that database by connecting to that, and we'll get the response. That response again will be sent to LLM to give the final response. So all these will be running in the pipeline actually, right? So here, yeah, here natural language to SQL using ChatGPT. This is one articles I think. Natural language to SQL. It's for Microsoft. Okay, here if I search with LinkedIn, right? They already implemented a production application actually. Okay, with this solution. Natural language to SQL, NLSQL. This is actually, yeah, this one. This is the production application in LinkedIn where they used the same technique actually. Whatever we have discussed. Yeah, chart with SQL, AI powered natural language to database queries. I think this is the article, good article. Go through this. Yeah, setting up the database schema, creating a database with SQL, the schema definition, break down the function. Okay, and create the tables schema, insert the data into categories, insert the retrieve category for okay, change, insert this, retrieve the products orders, insert. It is interesting actually. This is the actually solution for most of the RDBMS related problems. Okay, and here uh, give some of the prod applications where text to SQL is used. Text to SQL, we can say natural language, NL it will understand. Yeah, real world application that use natural language to SQL, self-service analytics BI tools, data warehousing and lake houses, customer support and CRM analytics, finance and e-commerce, risk and fraud compliance, HR and IoT.
ఒకసారి
uh,
కొద్ది పైకి వెళ్ళు. హెల్త్ ఒకసారి వెయిట్. హెల్త్ కేర్ కిందకి
Healthcare and life
హెల్త్
sciences,
కేర్.
clinical queries, diabetic patients over 65 admitted in 2024 translate into condition is admission date filters and research
Okay,
research
patients
cohort.
with HbA1c greater than 8 and no statins in last 12 months composers condition lab and medical science. Yeah.
IoT
I
operations
was looking something similar అందుకని నాకు
okay.
ఒక చిన్న ఐడియా ఉంది. మనం ఒకసారి
Hmm.
చేద్దామంటే చిన్న
Hmm.
యాప్ ఏమన్నా చేద్దాం.
Okay.
I use a continuous what do you call this device, freestyle Libra 3 continuous glucose monitor. So I'm thinking ఈ continuous glucose monitor నుంచి it keeps sending my glucose information, so which is showing as 106 now. This is the today's my glucose. So ఇది రియల్ టైమ్ లో వస్తుంది కాబట్టి డేటా రియల్ టైమ్ లో దిస్ మై సెన్సర్ which is stick on my hand keep sending this data to the app. I'm looking at API or some form where freestyle libre about వాడదంట ఇది. దీని నుంచి they connect this to apps that deliver insulin. అంటే he already exposes some form of API where this app can share data with some other guy. or sir, external system, third party system అన్నమాట. So um, maybe it will be an interesting application if we can crack how we can transfer this data using whatever Kafka ఏదైనా
Hmm.
ఏదైనా మెథడ్ ద్వారా కంటిన్యూస్ గా ఒక వెక్టర్ డేటాబేస్ ని అప్డేట్ చేస్తూనో చేసి ర్యాగ్ రియల్ టైమ్ ర్యాగ్ వాడి ఒక యాప్ తయారు చేయొచ్చు where
Hmm.
user can actually, instead of looking at the app, maybe they should be able to speak to it and get the answer.
Hmm.
అలాంటిది ఏదన్నా. So I'm just speaking out loud.
Hmm.
Yeah. Uh,
Okay. Yes, yes, that can be
sure.
done. Okay. So this is very interesting actually. Most of the companies have data in their RDBMS systems, right? But
Mm.
we could not. I mean, we cannot input or create embeddings and store in, right, because data is very huge and we will have. I mean, we cannot put everything into vector database because vector databases have limitations actually, right? Uh, Up to 500 GB only. I mean, officially it is acceptable. More than that, again, it will crash or it would impact the system's
Mm.
performance. It would impact the system performance actually, right? So this is the solution actually, but this has many problems. I mean, the accuracy and all depends on how well the schema is designed. If there are too many complex relationships in the database, that is also a challenge, right? Say for example, sometimes if you want to retrieve the data from the database, right, we have to join. I mean, based on the requirement and based on the complexity, we have to join some 5 to 10 tables or 10 to 15 tables into a single query and fetch the data, right? So that
Mm.
time there are challenges actually. I mean, LLM might not understand the overall context among the schema or whatever tables, and that might go wrong sometimes. Okay, so but yeah, again, to improve the efficiency or accuracy, we have to write very good prompts actually, right? So here,
And also schema naming, table naming, column naming,
uh,
and kuda, because
yeah,
yeah, I think my guess is you you don't give additional metadata how to understand that individual things in the schema, right?
mm,
Maybe you will pass, yeah, okay, they below on all tables, all columns, what types. Yeah, I don't know.
mm,
Yeah, how
yeah,
well
yeah.
you name it and yeah, give good prompts for DB schema. Hmm.
Mm, mhm. Yeah, we have to like this. You are a senior data architect from the following business queries. Entities relation to one to many. Consider, okay, paste it, some examples also, questions actually. Here we have to give like this questions. Uh, all should be in the prompt only. Give these data sources and fields, paste some sample schemas or CSV address. Okay, logical schema, star and Slovak, give design, vector strider schema to ground NL to SQL. Use this to add vector store and holds schema documents. Column doc describes.
Hmm. Yeah,
Mhm. Here,
schema docs, column descriptions. Okay, yeah.
here we have RDBMS,
Double purpose gradient row.
with 10 TB of data. So we want to build a chatbot to work with that data. So how to implement that?
Hmm.
It is reading all articles. Here, Perplexity, they are doing amazing job actually here. See, it is reading all NLT SQL, chatbot, autonomous database, select a robust text SQL. All these are all these solutions only. Blueprint to build an application chatbot or 10 RDBMS target, conversational agent dot RBAC, high level architecture, stack, middle tier, client, web tier, show, table and grids and charts, step by step implementation, analytics source, build a semantic catalog and vector sites, harvesting schema and column description lineage into catalog, embed this context and index into vector database. This one, see, embed this content and index into vector database for retrieval augmented grounding at interface at inference, include glossary of business
Mm.
terms. Vector schema and context retrieval is core technique to guide LLMs to correct the tables and columns and reduce the hallucinations in SQL generation. Retrieval and planning layer. SQL generation with guardrails.
Guardrail.
What is guardrails?
Guardrails are
Uh,
the limits that you apply,
Mini
right?
production. Hmm. Execution and
Bound
summarization.
boundaries, basically, controlled boundaries.
Written, written,
Guardrails is more like security kind of thing.
Uh,
written rich results, observability and feedback. Same. I mean, whatever we discussed now, same solution actually. Okay. So it is anyway. I mean, it retrieved from all other sources only and gave the solution. So
mm,
that's what I mean. There is a solution, but
yeah,
this is not 100% accurate because of the
and not easy as well as I understand.
Ahem.
You should,
Mm.
yeah, I mean, it is a significant work for sure,
Mm.
but right, depends on uh, the schema, your
Mm.
how well it is, how do you make it understandable, and
Yeah.
yeah.
And I
Mm,
had a discussion with Aruna and their team actually. Uh, they did a small POC. I mean, we discussed on the solution, and after that, they did a small POC, and it is really
mm,
working. It is really working actually. Okay, there they didn't have very complex joins actually. They're retrieving from some 2 3 tables, so it was giving accurate results. Like uh, I mean, what is the average rating, or what is the last? I mean, what are the positive ratings in the last 1 week or last day or yesterday? It is answering. It is building a query, and in the background also logs we can see all the the queries and see the output actually. So technically it works, but
yeah.
functionally there are challenges. So
So I think it depends on how narrow or wider the question can itself be, right? Like for a Swiggy, you don't need like 200 tables.
uh, hmm,
Or maybe, I mean, I'm just giving an example. There may be more than that, but
hmm,
okay. And the end user, for example, in my case, audit logs మీద క్వశ్చన్ అనుకో
hmm,
దాంట్లో ఆడిట్
hmm,
లాగ్స్ మీద అంటే నీకు హండ్రెడ్స్ ఆఫ్ టేబుల్స్ ఉండవు కదా, మేబీ 2 3
hmm,
టేబుల్స్ ఉంటాయి హార్డ్లీ
yeah,
నాకు
yeah,
తెలిసి.
yeah,
వేర్ డూ యూ స్టోర్ ద ఆడిట్స్ అంటే ఏ అసెట్ మీద ఎవరు ఏం చేశారు అని, ఈవెంట్ బేసికల్లీ ఈవెంట్ లాగింగే కదా అది.
hmm,
సో ఇన్ విచ్ కేస్ మేబీ యువర్ అప్లికేషన్ schema may be huge,
hmm,
but you may not need to train the vector DB
hmm.
with the whole schema.
Whole data, yeah, yeah.
I don't know. I'm just speaking out loud again. Like maybe only, okay, this is the schema that I am interested in for you to learn,
Hmm,
right? And I'll ask questions on these two, three, four, three tables, maybe something
yeah,
like that,
yeah.
which
So
can be a good starting point. Okay, so what is
mm,
this?
mm.
Shiksha
This is
Lokam.
this is this is another example actually from LinkedIn. I think someone posted, or I don't know. This
Mm-hmm.
there is a blog, I think, right? Yeah. Here the questions and see. I mean, it's good. I mean, this is again in the behind the scenes. It is, we know that it is in SQL only, right? So list top 5 bug titles and IDs that something like this.
Mallana Gowda. Mhm.
Malala Goda Biradar resolved.
Yeah. So this is
Hmm.
actually query and giving top 5. When was the bug is fixed? It's good. I mean, it's useful actually, right? So for the support team to react and address the, I mean, look into the problems.
ఇదేదో ఇంటర్వ్యూలో బాగా ఉపయోగపడిలో ఉన్నారు ఇది. ఇంటర్వ్యూయర్ అడిగితే క్వశ్చన్ దాన్ని వాయిస్ నుంచి టెక్స్ట్ కన్వర్ట్ చేసి దాని నుంచి ఆన్సర్ వస్తే మనం అది చదవటం. అంతే కదా. రైట్ అండ్ ఎస్క్యూఎల్ క్వెరీ టు ఫెచ్ ద యావరేజ్ సాలరీ పర్ డిపార్ట్మెంట్ అన్నాడు అనుకో,
తప్పకుండా అక్కడ పెట్టడమే ఫోన్.
టక్కన వస్తుంది.
Yeah, here the interesting thing is, I mean, this will work with multiple sources also. Here MySQL is one RDBMS, and because in the code we have to manage, right? How to which database you are connecting, that is another component actually which we have to write here to connect to the database and retrieve the data. So yeah, so we should try, you know, these implementations actually, okay, and understand. But this is they will improve. Basically, there would be some additional changes in the framework and the schema generation and all, right? So I mean, definitely this is going to be one of the key areas or applications actually where many companies work on this actually. So definitely, I mean, for RDBMS related content, actually this is the solution, okay. So if this becomes more solid and, you know, more accurate and all, many companies will adapt to this, right? Because this would address many problems actually, right? We can build a complete production support system only to answer. There would be some queries and all, right? Like based on the data, system should be able to respond actually, right, to the consumers or their customers and all. So this will really help actually, this approach. No, but
And maybe this can be integrated with development tools, right? Maybe Todd, SQL Plus, right? Wherein the developers themselves can give the prompt. Generally, what we do, we log into database and we start writing queries, right?
yeah,
And we prompt on ourselves in the mind.
right.
And then we'll try to put it in the actual SQL syntax. But whereas now you should be able to type in and it should generate this SQL. And you just review it, execute it.
Yeah.
Right? So I think maybe that can be an developer assistant which we can build integrating with this LLM. And so they can just prompt it and then they'll get the query.
And
Right?
yeah.
Even now in Copilot, in Visual Code or whatever, if you ask to write a query, you give the table name, it's generating the query and it's giving the output, right? So, and you're putting it in your whatever file.
Right.
So, like similarly we can do this for integrating with this tools.
Yeah.
That can be a plugin also.
Yes.
I can make it as a plugin, wherein when I click that, it should, when I type in the text, it should give me the query.
Okay. So what is the time now actually, Prasad?
నాకు
9:50.
2:20 అయింది నాకు.
Oh, okay. So 5 minutes
maybe
actually we'll
10
close.
minutes, we'll close it.
We'll wind it up in 5 minutes, 5 to 10 minutes. I think this week you can, I mean, you can study all these topics and concepts actually, okay. I will quickly touch upon GraphRag. This is also important. We'll see advanced techniques next session actually. GraphRag, I will quickly give the overview actually, what exactly is and what is this. Okay, so here yeah, with this traditional RAG approach, you have text, I mean, you have PDF documents, okay. The PDF is in basically PDF, it has some paragraphs and all, right. So here when we create tokens and when we create embeddings, it will go with the words tokens, right. So it really, I mean, you have some information in the paragraph 1, and in paragraph 2 there is some relation with the paragraph 1. Okay, so basically there are some relational context. Okay, there are some relationship among the data which is there in the PDF files, right? So sometimes we will have data something like that. Okay, so here what is, I mean, what is the problem here is with this our traditional RAG approach. Okay, when we take the 1,000 by words, I mean chunk, and then generate, right? We will miss the relationships actually. Like, I mean, as a given example, in paragraph we have 900 words, I mean 900 characters, whatever, and in the paragraph 2 will go as another chunk, right? Not in the first chunk, right? So basically from between paragraph 1 and paragraph 2 there are some relations among the functionality. Okay, so that is missing. I mean, when we ask some queries which are related with the relations, uh, with this traditional RAG approach, basically with the traditional RAG pipeline, it doesn't answer. Your chatbot actually doesn't answer because it is missing the relations actually. Because in vector database actually uh, we don't maintain relations, right? Here because of this setup actually. Okay, so that is the problem actually. That is the problem, and our responses are not accurate, and it won't answer. Sometimes, most of the times, it won't answer only. Okay, the relations. If you ask any relations related to the queries, right, among the data which is there in the source, your chatbot actually doesn't answer because the source itself, the vector database itself, doesn't maintain those relations. So that is the problem. Okay, so to address this problem, this is really interesting. This is actually this concept is actually introduced by Microsoft. Okay, so the solution is actually graph RAG. How many RAGs actually? RAG only one big, topic in AI. If we are the experts at RAG, right? So this is enough to get the job actually in AI. Okay, so because many people don't know about this, and they know, whoever knows also, they know very basic things in RAG, and no, they will not be able to implement solid applications actually. Okay, so with all these concepts, like with advanced techniques, with graph RAG, with with real-time gen AI, with natural text to SQL implementation. Okay, so I mean, there would be many opportunities actually if we learn all of them, and if we become experts at these, it's really really good for us, because as a developer we have to build the application, right? So again, the quality of the application or the accuracy of the application actually depends on how we implement that, right? How we what techniques or what frameworks or what concepts which we have used to build that application. So that's why that is the key actually here, right? So Microsoft actually came up with the solution to address this problem actually, that is actually called graph RAG. Graph RAG actually, it is again this is actually inspired from GraphDB. GraphDB, you might heard about Neo4j, right? Neo4j is again, it's an open source. Actually, they built a database called GraphDB. Okay, GraphDB uh, basically GraphDB and RDBMS, we know that. I mean, RDBMS, we know that it maintains relationships, and it's purely, I mean, transactional DB, right? So GraphDB is basically it is represented as a graph, and it maintains relations actually in the form of that edges actually, the node between
Nodes.
yeah, nodes actually, right? Yeah.
Nodes.
So here basically we can represent that unstructured data in GraphDB with these relationships actually, like the I mean, if you have some data which is related with some parent data or child data, so that can be represented in the form of graph actually. Okay, so the whole concept actually, the rag graph, sorry, graph rag is actually inspired or derived from graph db, and internally it uses neo4j also. Okay, so when we implement graph rag, we have to use neo4j. Neo4j is basically graph db, okay, to store relations actually. Okay, so here how graph db will be represented is like here in the form of nodes actually. Here nodes actually represent entities. Okay,
Mm.
entities. Here you have a node, and you have node here. This is actually edges, right? The connector between node to another node. This actually maintains relationship with the other node. You have entity 2, you have entity 3, here you have entity 4 and entity 5, right? So it actually maintains the relation among the nodes actually in the form of edges.
Is
And
each node a chunk here?
each node basically it's an entity actually. Entity, uh, not exactly chunk. That depends actually how we define. I mean how we
Mm.
derive, how we generate actually. But the whole here still we didn't jump into rag graph rag actually. We are talking about only graph db here. Graph
Mm-hmm.
db, in graph db it will be represented like this actually, and
Mm.
all unstructured data will be represented in the form of graph db, which is actually from neo4j. This is actually widely used graph databases, graph database. Build what others cannot, fraud detection, and this is yeah, this is the representation. Yeah, many companies are using this neo4j for representing the
Mhm.
relations using the graph database. Okay, so yeah, but here the point here is actually you have employee and data, and you have department, right? The employee and department, employee will be represented by one node, department will be another node. The relation between employee and department will be represented in the form of
Mm.
this edge. Okay, edge, this is actually called edge. And entity and node and edges, nodes basically represent entities, and these edges actually represent relationships among the entities actually. Okay, so basically this is to represent unstructured data. We can put anything, and it can be represented as a graph database. Okay, once we store in the graph database, we can query and fetch the data. It will fetch the relationships also. Okay, so many companies are, even yeah, Microsoft Azure is also using, AWS is also using, Google Cloud is also using same tech stack. Yeah, so do some study on Neo4j to understand what exactly graph database is. Okay, once you understand the graph database, will come to you can come to
Mm.
graph rag. So because
Yeah.
behind the scenes actually it is again Neo4j only. Graph rag here, graph rag here we can see it is from actually Microsoft. That is a good thing because here welcome to graph rag. So this is how actually they posted. Okay, and getting started. Graph rag versus baseline rag. Baseline rag is the normal rag actually. Your technique to improve the LLM outputs in real world information. This technique is an important part of the most LLM based tools. The majority of rag approaches use vector similarities as the search technique, which we will call baseline rag. Graph rag uses knowledge graphs. So basically knowledge graphs are actually these graph representations which can be built using Neo4j to provide the substantial improvements in the question and answer performance. When reasoning about the complex information, RAG techniques have shown promise in helping. LLM is not trained, and okay, such as in enterprise systems. Okay, to address this, the tech community is working on the developing the RAG. Microsoft researchers' new approach is actually graph RAG, creates a knowledge graph based on the input. Okay, the data which we give. This graph, along with the community summaries and graph machine learning inputs, and are used to augment the prompts and data. Graph RAG substantial improvement in the answer. Okay, and Yeah, so this is the overall. I mean, here in the next session we will implement one application and see here there are some steps actually to set it up GraphRag locally. This will run local actually. We have to install this Python library. Okay, and yeah, we can run this running locally, and here we can test it actually. What are the top themes in the story? The GraphRag, it will still we didn't integrate with the AI actually. It is querying, creating and querying from GraphRag actually, GraphDB. I mean the GraphRag implementation, and the implementation part we will discuss in the next session.
Yeah.
So do some study and research and understand this, how what is actually GraphRag and how it will address the problems. Okay. So yeah, so that's it actually. I think we covered this one, and advanced techniques we will see in the next session. Both will continue. I mean, both will continue in the next session.
You can stop the recording, I think.
Just a minute.